So we are looking at Unit 8, Day 4. And rumor is EQAO has been canceled. That's a rumor. It's coming from another school. I haven't been officially told, but that's the rumor. Okay? And I kind of knew that rumor about a week ago because I know Toronto Board already canceled their EQAO. Because I got friends in high places. Okay?
The rumors from FS, right?
Pardon?
The rumors from FS? Because,
It's actually was from like Clarkson.
really?
Yeah. But yeah, so some places know, some places don't know. When I get the official word, I'll post it on Google Classroom, okay? So optimization is the process of finding values that make a given quantity the greatest or least possible given certain conditions, okay? So for example, what is the largest area you can enclose for a given perimeter? So based on just yesterday's little assignment, what did you guys kind of learn? What is the largest area you can for a given perimeter? What was kind of like the rule you came up with? Hannah?
The square, so like...
A square? Okay, yep. So a square. Or we can say or, oh, that's not a good. Or equal side lengths would probably be a good way to term it, right? Equal side lengths. Okay. Yield the largest area. Okay. So essentially we're kind of working off this idea for the next couple of days. We're going to be looking at this today in class with the enhanced textbook, and then tomorrow we're going to be looking at it in some 3D figures, okay, as we get going. So I'm just going to do like a little overview. It's a very short lesson today, then we're going to write the unit test, and then you guys will have the rest of the class to work on the activity. The activity can be done in groups up to 4, okay? Essentially what I'm going to ask you guys to do is to make a slideshow presentation, something different instead of just like handing in work. You can make it like a presentation, like on a Google Slides, where you guys all add in of a shape, okay? Yeah.
This is the Unit 8 activity?
This is the Unit 8 activity. So we're going to start it now, okay? So then you have all of essentially the week to kind of get it done, okay? So this is just continuing on. So a perimeter and area relationships of rectangles. So summary. So this is kind of what you would have investigated yesterday, okay? Would have been for a 4-sided enclosure, the maximum area that can be enclosed is a square, okay? If fencing is not required on all sides, a greater area can be enclosed. Okay, so fencing is not required on all sides. So this is where we kind of get into some other questions. There might even be an enhanced question on this, okay? So what dimensions will provide the maximum area for a rectangle with each perimeter? So one of the ways we can kind of look at that is if we're talking about a rectangle. What is the formula for area of a rectangle, guys? Just a little reminder. What is it? Length times width, right. Okay. And then the perimeter, okay, is 2 times length plus width. Okay. So we can kind of use those two formulas to kind of give us a range to work in, okay, to kind of develop our ideas here. So what we're going to do is we've been given, in these questions, we have been given the perimeter. So we could say, perimeter 80 equals 2 times length plus width, okay? And what we can do is we can kind of isolate this down to give us, we can solve for L if we want to, okay? You kind of might remember this from a couple of units ago where we did stuff like this. So divide both sides by 2, okay? We end up getting 40 equals L plus W. And what we're going to do is we're just going to rearrange it to solve for L. Okay?
Good morning, Woodland. We'd like to acknowledge...
Okay, so what we've done is we're just rearranging to solve for L. So we're going to go L equals 40 minus W, because essentially all I did was I moved the W to the other side. Okay? So now what we can do is that we can replace, okay, our area. So I'll do this in a different color. Area equals length times width, right? Okay. Well, what are we saying L equals? What are we saying L equals? What did we come up with for L? Yeah, so in this situation, we're saying that 40 minus W times W. So what we've done is we've made our own equation, and this equation would give us what we call a quadratic formula, okay? Or it would give us a parabola shape. So it gives us an optimization or a maximization if we were to graph this, okay? So we can graph this equation if we want to, and if we can find the peak or the valley, okay, to let us know where the optimization is. But we can also use it in just a really basic sense, in that if we were to look at the values here, okay, if we were to pull them out of this equation, what we're saying is W could be 0 or W could be 40, okay? So we know that our answer lies somewhere between greater than 0 but less than 40, okay? So what you could do now if you want to, and this is part of the exploration, kind of what you did yesterday, is you could look at some of the side lengths. So you know that if one of the side lengths was 1, what would be the other side length of that rectangle? So if one side length was like 1 meter, what would be the other side length? 39, right? So again, it has to add up to 40, okay? Okay, if one side length was 2, what's the other side length? 38, right? Okay, so this is one of the ways to kind of look at it and to continue on, okay? And essentially what this is giving us is length times width, or vice versa, whichever way you want to put it, okay? And we can actually solve for the area of the enclosed figure, okay? And you're going to notice that each of them give a different answer when you do that, okay? So what you're going to be looking for is the maximum area enclosed in that, okay? So, I'm not going to dive too much into that because we're going to look at that in more detail in our enhanced textbook. So, after our unit test, okay, you're going to be working in groups, okay? Enhanced textbook. The first thing you're going to do with your group is you're going to read page 276, okay, to 284, okay? Then what you're going to do after you read is you're going to pick one scenario, okay, on page 285, okay, to 287. So I believe there are 6 scenarios given, okay? And then you are going to complete the assigned task, which is to make a graphical model or a numerical model, okay? I would like it done in, say, a Google Slides format so you guys could all be working on it at the same time and adding to it, okay? I will be posting it as an assignment on our Google Classroom, okay, separate from this lesson. And that's what we're going to be doing for the rest of the period after the unit test.